Day 2 of section 8.5, where we're adding and subtracting rational expressions. Today we're going to focus more on complex fractions. So a complex fraction is a fraction that contains a fraction within the numerator or the denominator, or it could be in both. Now when we simplify complex fractions, what we want to do is multiply the numerator and denominator, and when we do this, it's every term of the numerator and the denominator, by the least common denominator, or the LCD, of every single fraction. Then at the end, we want to simplify whenever it's possible. That means we are back to factoring and checking to see if anything can be reduced or cancel out. So when we have to simplify complex fractions, the first thing we have to do is find the least common denominator. So the least common denominator, we have to look at the two denominators, in this case, of the two fractions. Those two denominators would be 2 and 4. And to find this least common denominator, if you can't tell on your own, you can always go back to what we talked about in the past with the prime factorization. You can write out the prime factors of each of those. Now you have to look at where does each factor occur the maximum number of times. So we have just 2's as our factors here, and it occurs twice for the 4, which means our LCD is 4. We probably all could have told that already looking at the 2 denominator and the 4 denominator. So what this means we have to do now is we have to multiply our numerator, that 1/2, by 4, and we have to multiply our denominator, the 3/4, by 4. Now you're multiplying fractions by a whole number, so you may want to put that whole number over 1. Now when you multiply, you can either multiply it out and get 4 over 2 and 12 over 4, or you could cross reduce. 2 and 4 reduces to 1 and 2. Here you have 4 and 4, so those both reduce to 1's. Now if you multiply, you have 2 in your numerator. And in your denominator, you'd have 3. So 2/3, we cannot reduce that anymore. That would be our answer. It's a very basic example to start us out, but that's the same process we're going to use for all of our other examples. So for the second example, we have fractions in both the numerator and the denominator. So what we need to do first is find that least common denominator. So the denominators we're looking at are the 4, a 2, and an x. Again, some of you might be able to tell what the LCD should be right away. And if that's the case, that's fine. If you can't, you can do your prime factorization, which would look like this. Your factor of 2 occurs a maximum of 2 times right there for the 4. And then you have an x that occurs a maximum of 1 time. So multiply all that back together. Your LCD is 4x. So we have to multiply each term in the numerator and each term in the denominator by 4x. So to do this, I'm going to actually show that work a little bit more here. I'm going to take 4x, put it over 1, multiply it by x over 4. And then I'm going to have my 3/2. Show that I'm multiplying that by 4x over 1. So there's my numerator. My denominator, I'm going to take 4x times 2. And then I have my minus 3 over x. That's being multiplied by 4x over 1. So now I can go through and cross reduce. This 4 will cancel with that 4. This 2 makes this 4 a 2. This x would cancel that x. So now we have x times x, which gives us x squared. And we have 3 times 2x, that's a positive 6x. And in our denominator, we would have 8x, and we'd have minus 12. So all of the multiplication and simplifying is done except for the factoring of the numerator and the denominator to see if you can cancel any factors. So the numerator has a GCF of x. If we factor that out, we have an x plus 6 left. Then the denominator has a GCF of 4. Factor that out, you have an x minus 3 left. We don't have any factors that are the same in the numerator and the denominator, so this is just going to be our final answer. We're just going to leave it in the factored form. Our third example, now we have some binomials in our fractions. So again, looking at each of the denominators, we have an x plus 2. We have another x plus 2. And we have an x. So the factors of these would be x plus 2, x plus 2, and x. So maximum number of times the x plus 2 occurs is 1. Maximum number of times the x occurs is 1. So the LCD is x times x plus 2. So again, we have to multiply that by every term in our complex fraction. So we are going to have 2 over x plus 2 times x plus 2 over 1. That's our numerator. Then in your denominator, you would have the 1 over x plus 2 being multiplied by x times x plus 2 over 1, since the fraction. Then you have your plus 2 over x, and that's being multiplied by x times x plus 2 over 1. So these x plus 2's in the denominator, I'm going to put in parentheses because they are their own factors. Now if I go back through and simplify before I multiply, just to make life easier, the x plus 2's can cancel in that numerator. These x plus 2's can cancel, and these x's would cancel. So the whole point of multiplying by this LCD is you should not have any fractions within a fraction after you simplify your multiplication step. So our numerator here would just be 2x. Our denominator, we have an x, and then we have 2 times the quantity x plus 2, so we're going to distribute. That would be 2x plus 4. So we need to simplify in that denominator. So that would be a 3x plus 4. Again, looking at it, can you factor at all to see if you can reduce? Neither of those can be factored. So this is your final answer. Same idea with D. We have to find our LCD first. To do that, we're looking at the denominators of each fraction. So we have a denominator of 5, a denominator of x, and a denominator of 5x. So factors would be 5, x, and 5 and x. So 5 occurs a maximum of 1 time, x occurs a maximum of 1 time. So the LCD is 5x. So another way you could be showing your work, multiplying each term by that LCD, would be to write it next to the original problem, as long as you can be neat enough with this. I don't think people tend to have issues. It's kind of personal preference. So it would look like that. You can still go through and reduce. So the 5's can cancel. Here are the x's. The whole 5x cancels there. So now if you multiply x times x, you have x squared. You have 4 times 5, you have 20. Here you have just 1 times 6, so that's 6. 1 times 5x, that's 5x. So now we look at it. Can we factor it all? We cannot. The only thing we need to change is that we need to put that denominator in standard form, so the 5x should be first. Then this would be the final answer. All right, in our last example, it's a little bit more complicated because now, if we look closely, our denominators of our pieces of our complex fraction can actually be factored. So if this is the case, you want to go ahead and factor them. We can factor out a GCF of 3. You get 3x plus, or sorry, 3 times the quantity x plus 5. Here you can factor out a 4, and that would be leaving an x plus 5 as well. So now when we find our LCD, we're looking at the denominator of 3 times the quantity x plus 5, which has factors of 3, and that quantity of x plus 5. We have the x plus 5, which is its own factor. There is no other. And then we have the 4 times the x plus 5. So that would have factors of 4, and then the quantity of x plus 5. So 3 occurs a maximum of 1 time, x plus 5 occurs a maximum of 1 time, and 4 occurs a maximum of 1 time. So our LCD is 12 times the quantity x plus 5. Now if we go through and multiply each term by that LCD, this is a little bit more difficult problem, so I'm going to write out the work a little bit more. We'd have 2 over 3 times the x plus 5. And then we're multiplying by the LCD, which is 12 times x plus 5. And since they're fractions, I'm going to put that over 1. In the denominator, we would have 2 over x plus 5. That is its own factor, so I'm going to put it in parentheses. That is being multiplied by 12 times x plus 5. Again, putting that over 1 because we have fractions. And then we have 1 over 4 times the quantity x plus 5. Notice I'm using the factored form. Makes it easier to cancel and make my multiplication easier. I'm multiplying that by that LCD. So go through and simplify. Up here, your x plus 5s can cancel. You can also cancel that 3 and that 12, making that 12 a 4. You can cancel the x plus 5s here, the x plus 5s here, and this 4 brings this 12 down to a 3. So in your numerator, you just have 2 times 4, that's 8. In your denominator, 2 times 12 is 24. 1 times 3 is 3. Just simplify the denominator. You have 27. There is no common factor with 8 and 27, so this is the final answer. So if you need to go back and rewatch any part of the video, please do so. Otherwise, whatever time is left, you can use to start this homework. I will, on Monday, be checking the exam review that was due today, as well as these numbers 16 through 25.